Okay. So yan. So just last time, no, sa ating asynchronous discussion, there are two types of electrochemical cell. So when we say electrochemical cell, we have two solutions here wherein may electrodes dip into them. Okay? So kapag dinip mo yung electrodes sa kanila, they can either generate electricity or they can use electricity to allow non-spontaneous reactions to happen. Okay? So dalawa yung uri ng electrochemical cell natin. Number one is voltaic or galvanic cell in which nagkakaroon tayo ng spontaneous production of electric current. No? So ito yung mga type ng cell na makikita natin sa batteries. No? So 'di ba yung battery kapag pinagdugtong mo yung dalawang electrode, it will magkakaroon tayo ng circuit. So magfo-flow yung electron, hence ma-harvest natin yung electrochemical energy doon. The other type is the electrolytic cell, no? So, ano yung example ko dun last time? Yung mga gold plating. Suppose, itong nipper ko na to, ilublob ko to sa gold solution. May mangyayari ba? Magiging gold ba to? Hindi agad-agad, no? So, you have to apply electrical current so that this metal here will ano, so that yung gold sa solution, made-deposit siya sa aking metal. Okay? So, kinukuryente yung solution para yung ions ng metal kumabit sa surface ng metal. Okay? So, yun yung electroplating. So, alam nyo, saan ginagamit yan? Sa copper plating, sa mga, sa mga utensils sa bahay, no? Sa jewelry, mga silver plating, gold plating, no? Gano'n yung ginagawa do'n. Kinukuryente nila yung solution so that the metal ions will be deposited on the metal surface. Okay? So, yun. So, again, voltaic, spontaneous production of electricity or electric current. Electrolytic cell makes use of the electric current to drive the non-spontaneous reaction. So in constructing voltaic cell, katulad ng sabi ko last time, may dalawang compartment yan. So you have a solution and the electrode for your anode and the solution and the electrode for your cathode. No? So ano yung nangyayari sa anode? In the anode part of the solution, you have your oxidation reaction happening there. And in the cathode part of your cell, you have the reduction reaction happening there now. And oxidation and reduction reactions happen at the same time, no? So it happens when the electrons of the anode are transferred to the cathode as the circuit is completed, no? So pag pinagdugtong mo yung dalawang electrodes, dun na mag-start mag-flow yung electron, hence magkakaroon na ng kuryente. Okay? So ganun lang. So again, on the anode, you have your oxidation. On the cathode, you have your reduction reaction. So you can use those ideas now to actually calculate for how much electricity or how much voltage can be generated by your cell. No? So suppose meron tayong baterya sa cellphone, baterya sa laptop, baterya sa sasakyan. You can actually compute for the voltage that it can produce by just determining what species undergo what species undergo oxidation and reduction reaction. So alamin mo lang sino yung nag-oxidize, sino yung nare-reduce, no? And then pag nalaman mo na sino-sino yung mga nag-oxidize, reduce, you look at this SRP table or the standard reduction potential table. Hanapin mo yung corresponding E naught ng reaction na yun. So E naught pertains to the standard cell potential, no? So it will tell you how much voltage will this reaction give off or consume. Okay. So gagawin mo, hanapin mo sino yung oxidation, sino yung reduction. Then to solve for the E of the cell, you have to use the equation E naught cell equals E cathode minus E anode, no? So kung ano yung cell potential at the cathode minus the cell potential at the anode, that will give you the overall voltage of your battery, of your voltaic cell. Okay? So bago tayo mag-continue with the main topic for today, reviewin natin yung pag-compute ng E-cell. No? So, kuha tayo ng ilang example dito. Suppose we have this equation here. We have, for letter D, we have 3 moles of iron 2 plus 2 moles of aluminum producing 3 moles of iron and 2 moles of aluminum 3 plus. So, as I told you in the video last time, you must identify which of the chemical species undergo reduction or oxidation reaction. Okay. By just observing the equation, na kailangan na may mental nyo na to, no? So, by just looking at the equation, we can see that aluminum undergoes oxidation. So, si aluminum ang oxidation. Why? Because it's charge, no? Ano nangyari sa charge niya? From 0 to positive 3. So again, if you could still remember our first synchronous lesson, whenever the oxidation number increases, that means siya ay na-oxidize. No? So aluminum 3 plus, ito yung ating oxidation. Hence, ito yung ating anode. Okay? So again, pag oxidation, anode, no? So, kung nalilito kayo doon, meron akong tinawag last time na oxan red cat. So, si oxan red cat, pangalan yan, oxidation, anode, reduction, cathode. No? So, kung sino yung oxidation, siya yung anode nyo. Kung sino yung reduction, siya yung nasa cathode mo. Okay. So, yan, for aluminum to aluminum 3 plus, that will be the oxidation reaction. Hence, it is in the cathode compartment. No? Kumbaga, kung magdodrawing ka ng cell, nasa left side yan. And then you have Fe2 plus and Fe. What happened is that its charge decreased. No? So from positive 2 oxidation number, it went down to 0. So ibig sabihin, that is a reduction reaction. Okay, so Fe2 plus and Fe. So this is a reduction, hence this is in the cathode. Okay. So yan. So once we were able to identify which of the two goes sa anode, sino sa cathode, ano susunod na gagawin? We can now solve for the E cell. Okay. So E naught cell. Pag may circle na maliit sa taas, tawag doon ay naught, no? N-O-U-G-H-T, no? Naught. Maraming ganyan sa calculus, no? So, sa chemistry, may definition din yung naught na yan. Mamaya pag-usapan natin. Okay. So, when computing for the E naught cell, ang equation will be E naught cathode minus E naught anode, di ba? Cat minus an. That will give you the E of the cell. So, ngayon, we know the cathode reaction and we know the oxidation reaction. Let's look at the SRP table, no? Kung ano yung corresponding E values ng dalawa. So for the cathode, we have Fe to Fe, no? Fe2 plus Fe atoms, no? So tingin tayo dito sa table, hanapin natin si Fe 2 plus and Fe. Yun lang, ang dami nakalagay. Ito. Okay, so ito. So, dito sa baba, we have Fe2 plus Fe. Okay. So, mag-ingat lang sa pagtingin kasi baka mamaya Fe3 plus makita nyo. Halo-halo yan dito eh. So, iba yung Fe2 plus Fe sa Fe3 plus Fe2 plus at Fe3 plus 2 Fe. Okay. So, magkakaiba ng values yan. So, be careful when checking dito sa table. Just look at the chemical species, no? It doesn't matter if the equation is flipped or not. Teka lang. Ayan, low-bat tayo. Okay, so ganun lang. Just look at the chemical species available on the SRP table and look for the corresponding E naught value. Okay. So for Fe2 plus Fe, we have negative 0.44 volts. Okay. So for the cathode, that will be negative 0.44 volts plus E of the anode will be, ano yung anode natin? Aluminum 3 plus. Balik tayo sa table. Saan yung aluminum 3 plus? Ito. Ayan. So this is the cell potential for aluminum 3 plus aluminum. Okay. So that will be negative 1.66 volts. So pakisulat yan dito. Negative 1.66 volts. And we can combine the two. No. Minus pala, sorry. Ba't plus nilagay ko dun? Minus negative 1.66 volts. So we can now combine the two cell potentials to get the voltage of our cell. Okay. So solve natin. That will be negative 0.44 minus negative 1.66. The cell potential for this equation will be 1.22 volts. No? So yan yung ano, yan yung amount ng voltage na kaya i-produce ng reaction na to. Okay. So kapag 1.22 volts, that can actually power a small LED light. No? Possible ba talaga yon? Yes po. Ginawa namin yan last year. No? Nung ito yung topic namin before pandemic. No? So nakita nila ng mga student ko umiilaw yung LED. Ilulublob mo lang siya sa solution. It's liliwanag na. Okay. So yan. So hindi to joke lang. No? Legit to. Okay. So, yung ibang items, di ko sasagutan, ha? Okay, so, kayo na bahala sa ibang items. Okay, sige, ito. Practice pa tayo before we go into the main topic. Fe2 plus, MnO4 minus, producing Fe3 plus and Mn2 plus. Okay? So from these two equation, we identify which one is the cathode, which one is the anode, no? You can balance this, no? Pero since ang gusto ko lang naman ay E-cell, edi shortcut na tayo. We can identify which one is the oxidation or the reduction reaction by just looking at the oxidation numbers. Okay. So kung hindi kaya i-mental, i-balance. Kaso matagal. So ako, kaya ko i-mental to. So, bibilisan natin. Okay. So, paano po yung technique doon? No? Tignan mo lang yung mga mag-isang atom. Tignan mo yung oxidation number nila. Huwag yung grupo-grupo like this one. Okay. Doon ka sa tigi-isang atom lang. So, yan. We have Fe2 plus on the reactant side. On the product side, it turned into Fe3 plus. No? So, that means yan ay oxidation. Okay. So, yan ay oxidation. Yan yung anode natin. Okay. So bakit yan yung anode natin? Because the oxidation number increased, no? And we know that oxidation numbers increases whenever our reaction loses electrons, di ba? Okay, so yan. And then we have MnO4 minus Mn2 plus. That will be our reduction. No? So MnO4 minus Mn2 plus. That will be our reduction or our cathode. No? So once identifying which chemicals, no, alin sa mga substances natin yung mag-undergo ng oxidation, reduction, we can now solve for the E cell. Again, the formula, E net cell equals E cathode minus E anode. Okay. So ayan. So we plug in the values of the corresponding cell potential for the cathode and the anode. Okay, so for the cathode, that's MnO4, Mn2 plus, permanganate ion to Mn2 plus. So, asan yung permanganate ion natin? Hanapin sa table. Ayun, nasa taas. Okay? So, again, be careful kasi tignan nyo, oh, may MnO4 dito. As meron din dito. So, magkakaiba yun, ha? check nyo maigi yung equations. Baka kasi mapaghalo-halo nyo, mapag-jumble-jumble nyo yung SRP values. So, MnO4 minus Mn2 plus, yun yung gusto natin. Ito yon. And the cell potential is 1.51. Okay? So that will be the cell potential of our cathode. 1.51. 1.51 volts. No? For the anode, that's Fe2 plus, Fe3 plus. Again, be careful kasi magkakahawig yung mga species dito. No? So, kailangan mag-ingat. Nasaan yun? Okay, so ito yung Fe3 plus, Fe2 plus. Okay? So, yan. Fe3 plus, Fe2 plus. Be careful kasi katulad nga ng sabi ko kanina, merong dyang Fe2 plus to Fe, Fe3 plus to Fe, no? So, iba-iba yung cell potential value nila. So, kapag nagkamali ka kasi ng kinuha, mali ka na in the end, no? Wala na, finish na. Okay. So, for our anode, that's 0.77 volts, no? So, pag subtractin natin yung dalawang E values, so we get the E naught cell, 151 minus 0.77. That will be 0.74. So that will be the voltage that will register when we have a cell consisting of these two ions. No? So, ganun lang. Okay, sa module nyo, may nakalagay na ganito. Babasahin nyo yung part na to. Okay. Under standard state conditions, any species on the left of the given half equation, half cell reaction, will spontaneously react with the species that appears to the right of any half cell reaction located below it. No? So, ibig sabihin, yun daw ang tawag daw doon ay diagonal rule. So, ano meaning nun? Okay, so basically, what it tells us is that yung species on the top left will react on the species on the bottom left. Okay, so pag pinaghalo mo yung nasa top left and yung nasa bottom right pala, bottom right sabi na, di ba? Okay, so pag pinaghalo mo yung nasa top left and sa bottom right equation, spontaneous yung reaction na yan. Okay, so di ko na siya ma-zoom in. Bukas na lang ako ng module nyo mismo. Sana ma-zoom in ko siya na maigi. Saan ba yun? MS OneDrive. Okay. Buksan ko lang yung OneDrive ng module nyo. Ito ko ba nilagay yan? Sa Google Classroom. Dito pala. So, sagutan natin yan. Classroom. Okay. Excuse me. Excuse me po. Okay, so ito ay Electrochem. So, kwento ko yung diagonal rule, no? By the way, kung familiar kayo, ako kasi gumawa na ito, kaya kung ano yung nandun sa lecture guide ko, yun din yung nakalagay dito. Okay. So, paano pagka-explain ko, yun din nakalagay dito. Kasi, syempre. Ayan. So, kwentuhan natin yung meaning ng, meaning na itong diagonal rule na to. So, sabi sa diagonal rule is that yung species on the top left of the SRP table will react with the species on the bottom right of the SRP table. So, ano meaning nun? So, itong cerium 4+, no, it will react with silver. Okay. So, magkakaroon yan ng, redox reaction. And that is spontaneous. Ibig sabihin nun, positive yung voltage na makukuha mo doon. Okay. So, ang chemicals na nasa taas ng SRP table, sila yung most likely mag-undergo ng reduction reaction. And yung chemicals sa baba, sila yung most likely mag-undergo ng oxidation reaction. Okay? So, yun lang yung concept niya. Yung nasa taas, siya yung mag-undergo ng reduction. Yung nasa baba, yun yung mag-undergo ng oxidation. No? Okay, so pag kinuha mo yung cell potential nun, positive yun. So, ibig sabihin, voltaic cell yan. Okay. So, ibig sabihin nun, itong cerium 4+, this can react spontaneously with silver. Okay. This also can react spontaneously with mercury, tin, nickel, and aluminum. So, kapag ito ang iyong reduction, itong mga ito yung mga pwede mong anode, no? Or ito yung mga pwede mo i-oxidize. So, this will react with this to form the products. This will react with this to form the products. Okay? So, kunwari, ito naman, you have tin 2+. Saan siya magre-react? No? So, saan magre-react yung tin 2+? It is a species on the bottom right. No? So, ito yung tin 2+. So, saan siya magre-react spontaneously? Dito sa nickel and aluminum. So, it cannot react with mercury, silver, and cerium 3+. Hindi siya magre-react sa nasa taas. Yun nasa baba. Okay? Kasi kapag ito, pinagsama mo with these chemicals here on the bottom right, magpo-produce yan ng voltaic cell. No? So, that means spontaneous yung reaction. Okay, so tignan natin yung application niya. Question 1. Will tin react with Ag plus to Ag? So, will tin reduce Ag to Ag plus? No? So, hanapin mo yung tin. Ito yung tin. Okay. So, will it react with silver to produce Ag? Okay. So, will this react with Ag? Isipin mo lang yung diagonal rule. Kapag sila ay naka-diagonal to the right, okay, so ang tawag natin doon, back, di ba may forward slash. Pag naka-backward slash yan, okay, so pag naka-backward slash yan, dito, tas dito yung nasa baba, ibig sabihin magre-react sila. So, Ag will react with tin because of diagonal rule. Sabi natin, this can react with this. Okay. So, tin will reduce Ag plus to produce Ag. No? Okay. Okay, so sabi natin dyan, yes, it is possible because of diagonal rule. And if you solve for the E cell, that will be positive. Okay, so yun. So yun lang. Meron pa dito sa dulo. Okay, so kunwari ito yung question. Sa mga modular, alam nyo na gagawin nyo. Okay. Hint lang. Okay, so sabi ko sa inyo, kunwari ito yung SRP table. Ano gagawin natin dito? Yung species on the top, they are most likely na ma-reduce. No? And yung mga species sa baba, sila yung most likely ma-oxidize. Okay? So, ito yung mga most likely mag-undergo ng ng reduction reaction. Ito yung mga most likely mag-undergo ng oxidation reaction. Okay? So, yung mga terms na reducing agent, oxidizing agent, na nilagay ko na yan sa module niyo. Okay? Okay, so ganun lang. Again, diagonal rule. Sagutan natin isang item lang dito. Will lead reduce this to Fe2+? Tignan mo yung lead. Ito yung lead. So, saan pwede mag-react si lead? Ito yung mga nasa taas na left, no? So, ito yon, ito. Cobalt, iron, and I2. Okay, so will lead reduce Fe3+ to Fe2+? Will this react with this? Yes, ang sagot na. Why? Because of diagonal rule. Sabi natin, ito may react with the species on the bottom right corner. So, ito pwede yan mag-react dito. Okay. So, that means sagot dito sa EI, yes. Lead will reduce Fe3+ to produce Fe2+. Okay. Yan. So, ganun lang. Ano lang naman yung concept. No? Pag hindi kayo sure, you can solve for the cell potential, for the E value. Although, it will be more convenient no, to just use the diagonal rule. No? So that means, for example, this can react with this. Okay. So dun siya pwede mag-react sa mga nasa bottom right. No? So yun, spontaneous yun. What if yung question nyo, sir, will it react with any species on its bottom part? No? React ba yan dyan? Sagot ay hindi. No? If you compute the E cell, negative yan. Sir, will this react with the species on the top right? No? So, hindi rin. No? Kasi ang sabi ng diagonal rule, ang allowed lang ay diagonal downwards. No? Pointing to the top, bottom right. No? So, hanggang dun lang yung mga pwedeng reaction. Hindi pwedeng pataas, hindi pwedeng directly nasa baba niya. Only the diagonal. No? Okay. So, yun lang. SKL. So, ano pa? Ayan lang. So now let's focus now on the more on the main topic natin. So let's go with the thermodynamics of redox reaction. I don't know what happened to your thermodynamics, pero hopefully you encountered some terms, no? Kasi magagamit natin sila dito. Okay? So yan. So let's talk about the thermodynamics. No? So according to thermodynamics, no, when we want to move objects, we are doing work. No? So work is the displacement of the object due to unbalanced forces. So in equation, that will be W equals negative FD, no? Where F is the force applied to the object and D is the displacement of the object. So usually horizontal displacement yan, no? So yun yung work. Sa electrochem, may work din, no? Kasi aning gumagalaw sa ating system dito? Ano yung gumagalaw sa electrochem? Yung electrons. Saan siya gumagalaw? From anode, pupunta siya to cathode, no? So that means, as the electron moves around the circuit, no? As the electron moves around the circuit, there is a work involved in that process. No? May work involved sa movement ng electron. No? And the work of the movement of electron to complete a circuit can be calculated as the charge times the potential difference. Okay? So, ano yung potential difference? Yun yung E cell. Okay? So, ano yung charge? Yun yung fundamental charge. No? Yung, ano yun? Kalimutan ko yung value. Nasa calcu yun eh. Yung lang. Saan ba yun? Okay, so ano yung charge, no? Nahanap ko sa calcu. Ngayon, yung Faraday's constant sa calcu. Yung constant number 22, yung letter F na malaki. Okay? So, yung charge, that is just the product of the number of electrons moving in a circuit times its Faraday's constant. No? Ito mo makukuha yung total charge ng inyong system. So, pag pinag-multiply mo yung charge and the cell potential, that will give you the electric work. No? Okay. So, in this case, no, marami kasing conversion yung joules, no. Pwede siyang kilogram, meter squares per second, no. Second square. For this case, an joule will be equal to the coulombs of charge, no, times the voltage, no. Okay. So again, ano yung charge? Yun yung coulombs of the electron. Coulombs talaga basa nila dyan. O, yung potential difference, ito yung nasusolve natin na E cell, no. Pag pinag-multiply mo yung coulombs and yung voltage, you will get the electrical work in units of joules. No? Okay? So in equation, the equation form na, the electrical work in our electrical systems or in our electrochemical system will be negative NFE. No? When you multiply N and F, you get the charge. No? So, ano yung N? Ito yung moles of electrons. No? Ano yung F? Ito yung Faraday's constant. So, ano po yung value ng Faraday's constant? Nakalagay dito. 96485 coulombs per mole of electron. So, again, work electrical is negative NFE cell. Okay? So, N is the moles of electrons. F is the fundamental charge. Okay? Or the Faraday's constant, and E is the cell potential or the cell difference. No? Yun na solve natin kanina. Okay? So, yan. So, yan yung formula. WLE, electrical work is equals to negative NF E cell. N moles of electrons, F the Faraday's constant, and E cell, yun yung kinocompute natin kanina pa. No? Okay. So, yan. So, may relationship itong electrical work with thermodynamic quantities, no? Especially yung Gibbs free energy or delta G. I don't know if na-cover nyo yun, no? Pero if hindi, sige, wala tayong magagawa. No? So, what is yung work? No? So, yung work, equivalent yon with the delta G. So, ano ba yung purpose ng delta G? So, the free energy change tells us ano yung maximum work sa system. Okay, so basically, kung ano yung delta G, yun yung WL, no? So, sabi kasi ng definition ng Gibbs free energy, siya yung maximum work, no? So, that means delta G is equals to the maximum work in your system. Since we are talking with electrochemistry, ang maximum work natin ay equivalent sa electrical work, no? So delta G is equals to WL, no? Electrical work, no? Okay, so if you plug in the equation for the electrical work with the delta G, you will get the equation delta G equals negative NF E cell. Okay, at standard equation, we express this at standard conditions rather, we express this equation as delta G naught equals negative NF E naught cell. No? So ano ba yung standard condition? So kapag standard condition, ang sabi lang doon, the temperature is 273.15, okay? And the concentration of the cell is 1 molar each. No? So yan. So again, ang equation natin for the thermodynamics of the cell will be delta G equals negative NF E cell. Okay. So at standard conditions, all you have to do is to write small circles sa taas ng G and E. No? So yung small circle that will tell us na we are at standard condition. So ano meaning ng standard condition? We are at room temperature and 1 molar concentrations. Okay. So, dun sa discussion ng sa discussion ng thermodynamics, I don't know if na-cover nyo yun. According to the thermodynamic part, no, before ako, delta G is also equal to negative RT, L, and K. No? So, R is the gas constant in energy units, T is the temperature in Kelvin, and K is the equilibrium constant. No? I don't know if you could still remember your equilibrium constant noong senior high school, pero if not, and I will refresh it later. No. So sabi sa ating thermodynamics, delta G equals negative RT ln K. Sabi sa electrochem, delta G equals negative NF E cell. So if we combine the two equations, since parehas yan delta G, we will arrive with the final equation E naught cell is equals to RT over NF ln K, where R is the gas constant in energy units, T is the temperature in Kelvin, N is the moles of electrons, F is the Faraday's constant, and K is the equilibrium expression or the equilibrium concentration or the equilibrium constant. Okay? So, tatlong equations yung kailangan natin isabuhay dito. So, anong equations yon? So, that will be this one. Same lang naman tong dalawa. Okay? Yung isa, standard condition. So, again, paano muli malalaman kapag standard condition? When the temperature is 298.15, okay? So, that will be 298.15 Kelvin or 25 degrees Celsius, and ang concentration ay 1 molar, and ang pressure ay 1 atm. So yan yung sinasabi kapag standard condition. Paki-note na lang. So these two are equivalent. Ito ay standard, ito ay yung general. Okay. Ano pa yung isang equation na important? This one. So according to thermodynamics, delta G can be calculated from the equilibrium constant. So that's negative RT equals, negative RT ln K. No? So ginawa dyan, pinagsama ito, pati ito. So we get this final equation. E naught cell equals RT over NF times ln of the equilibrium constant. Okay? So yan. Yan. So when temperature is 298 Kelvin or 298.15 Kelvin, we can simplify the equation into this. No? Yan. So ito na yung mga shortcuts na lang. Okay. So ginawa doon, pinagsama-sama na itong mga numbers na yan. So you can just simplify the equations we listed earlier as either of the two. One is in the ln, the other is in logarithm form. No? Although ako, I prefer the ln. Mas madali gamitin yung ln kaysa sa log. No? So, sir, ano yung kakabisaduhin namin yung equation? Okay. So, itong apat na yan, basically, tatlo lang yan. Okay. And then, itong dalawang, may check na to. Actually, di ko kinakabisado yan. No? Tinatype ko na lang yan sa calcu as is. No? Okay. So, yan. So by just knowing the delta G, the E cell, and the value of K, we can predict whether the reaction is spontaneous or not. No? Sabi natin kanina sa voltaic cell, when E cell is positive, then spontaneous yon. That means the products will be formed. Kapag ang E cell mo ay negative, ibig sabihin non-spontaneous yon. So pag sinabi natin non-spontaneous reaction, yung product aatras pabalik sa reactants, no? Babalik siya doon, no? So yun yung negative E cell. So again, positive E cell, spontaneous, ibig sabihin yung reactant magiging product. Yun naman yung common, 'di ba? Pag negative yung E cell, that means yung product babalik sa reactant, which is uncommon. So that's why we call it non-spontaneous, no? So that means if your E cell is positive, the value for delta G is negative, no? Okay. Bakit? Kasi according to delta G, kapag negative siya, spontaneous yun. No? Okay. So ibig sabihin ng E cell ay positive, delta G is negative. No? And the value of K is greater than 1. No? So that means it will favor the formation of your product. Kapag negative yung E cell mo, delta G is positive. No? If you could still remember yung inyong thermo, kapag positive ang delta G, non-spontaneous. No? So, ibig sabihin nun, E cell is negative. Paatras yung reaction. No? So, hindi siya mag-form ng products. Rather, it will form the reactants. What if zero yung E cell or yung delta G mo? So, kapag zero yung E cell or yung delta G mo, that means nasa equilibrium na siya. Walang nangyayari. Okay? So, walang nangyayari sa system mo. Ano lang siya, nakatenga lang siya dyan. Okay? So, yan. So, again, positive E cell means negative delta G and your K is greater than 1. No? Okay, so yan. So, ano meaning nun? Kapag ang iyong E cell positive, delta G is negative, ang K ay greater than 1, that means spontaneous yon. When I say spontaneous, your reactants will convert into products. Kapag ang E cell ay negative, that means positive ang delta G and K is less than 1. And that means it is non-spontaneous. So, it will form the reactants. No? Aatras yung reaction pabalik. Whenever your E cell is 0, that means your delta G is 0 and K is 1. No? So, kapag ganon, ano yan? Stagnant. No? It is already in equilibrium. Okay? Ang dami kong sinasabi, no? So, practicein na natin na yung mga sinasabi ko. Okay, so let's try these problems na here. Calculate the equilibrium constant for the following reaction at 25 degrees Celsius. No? Letter A, we have tin plus 2 moles of copper in equilibrium with tin 2 plus and 2 moles of copper 1. Okay. So for us to solve for the equilibrium constant of this equation, paano yon? O ilatag natin lahat ng equations na alam natin. Ano alam nating equation? Delta G naught equals, ano yan? negative RT ln K. Ano pa yung equation na sinabi ko kailangan alam natin? Delta G naught equals negative NF E naught cell. Okay? Tapos ano pa? Ano pa? Yung E naught cell equals RT over NF ln K. So, yan yung mga equations na sinasabi ko na maging familiar. Okay? So, anong gagamitin natin dito sa tatlong to? No? Pag ganito yung question nyo, it involves the equilibrium constant and your redox reaction. You can use this na lang. Okay? So, okay, pwede mo rin naman ito gamitin kasi ano yung hinahanap sa atin? ln K, ay yung value ng K. Yan yung equilibrium constant K, di ba? So, kung gusto mo hanapin yung value ng K mo, you can either use this top equation, ito, yung may delta G, pwede rin naman yung E cell. Okay? So, you can use either of the two. Pero, ano yung problema natin? May binigay ba sa ating delta G? Wala. So, walang binigay na delta G sa atin. So, that means we can only use the bottom equation. Okay? So, we can only use this one. So, to solve for K, ano yung kailangan alamin? Yung E naught cell. Okay. So, let's solve for the E naught cell. Let me rewrite. E naught cell equals RT NF ln K. Okay. So, since we are looking for the equilibrium constant K, asan yung K? Nasa loob ng ln. So, how are we going to extract K from the ln function? Ano ginagawa natin? Basic calculus to. Ano gagawin mo para matanggal yung K sa ln? Mga mathematicianist natin dyan. Kung pwede kayo gumamit ng mic. Ano gagawin ko sa ln K para matanggal yung K sa loob ng ln? Sirit na. Exponential function. Okay, so exponential function yung katapat ng K na nasa loob ng ln. Diba, remember your algebra. Ano yun? ln x. Gusto mo kunin yung value ng x, all you have to do is to, gawin mong exponent to ng exponential function mo. Okay, so e raised to ln x, what happens is that the ln and the e will cancel out, giving you the value of x alone. Okay, so that means, kung gusto natin palabasin yung k, which is yung talaga yung gusto naman natin gawin, ika-cancel natin yung ln. How? Gagawin mong exponential function itong equation. Okay, so paano yun, sir? Ganito lang. Bago ka mag-exponential function, all you have to do is to cross-multiply this term to the other side. Okay? Lipat natin siya sa kabilang side. Okay? So, paano yun? So, when I cross-multiply this, NF will be on the numerator. RT will be on the denominator na. Okay? So, let's do that. So, ln K equals E naught cell NF over RT. Then, since we are solving for K, you take the exponential of the equation. So when I say you take the exponential of the equation, you exponentiate the two parts of the equation, yung left side and yung right side. No? Paano yun, sir? Ganito lang. E raised to ln K, then E raised to whatever this fraction is. Okay? So, gagawin mo siyang exponent ng exponential function mo. That will be E naught cell NF E naught cell NF divided by RT. Okay? So what will happen to E and the K, E and the ln K? Magka-cancel yung E and the ln, giving us K equals exponential of E naught cell NF over RT. Okay? So, ganun. That's how we derive for the value of K. So, paano yon? Gagawin mo, you cross multiply these terms, lipat mo sa kabila. So, you have this equation na. Then, what's next? You take the exponential of the both sides of the equation. So, when you take the exponential of both sides of the equation, E and ln will cancel out so that K can be extracted from the function. So, ito na yung ating working equation. So, ano na gagawin natin? Let's solve for the E cell. Ano yung N, ano yung F, ano yung R, ano yung T. Okay? So, sagutin natin kung ano yung mga yon. Ayusin ko lang tong equation ko, ha? May space pa. Wala na. Purong ka na lang to dito. Okay. So, ito yung ating working equation. Yan yung gagamitin natin. Box natin ng yan. Para kapag kunwari nakakita kayo ng problem na ganito, ito na gamitin yung equation. Dinerive ko na para sa inyo. Okay. Sagutin natin, ano yung E not cell? Identify mo sino yung cathode, sino yung anode, then solve for the E not cell. Okay. Okay, so let's do that. Let me rewrite the equation sa baba. Sn producing Sn2 plus. Paghihiwalayin ko siya kasi ibabalance ko to later on. Kwento ko kung bakit. Okay. So by just looking at the equation, what we have is that yung tin, ito yung na-oxidize, no? So that means ito yung anode mo. Paano na-oxidize yan? Just look at the oxidation number. So what's the oxidation number of tin? This is a free element, so yan ay 0. On the product side, what's the oxidation number of tin 2 plus? Sinabi ko na, 2 plus. Okay. So tumas yung kanyang oxidation number, that means ito ay oxidation. Okay. That means yan yung oxidation, ito yung reduction. So ito yung cathode sa baba. Okay. Solve na natin yung E not cell. Okay. So solving for E not cell, urong ko lang tong equation na to dito. Solve natin yung E not cell. E not cell. E cathode minus E anode. Okay. Cathode, hanapin natin yung copper 2 plus to copper. Okay. So, hanapin natin dito sa table. Copper 2 plus copper. Ang daming nakalista. Ito, nakita ko na. Suggestion ko lang, no, after this class, upload ko naman tong video mamayang gabi. Panoorin nyo ulit, no? Kasi mabilis ako makakita dito sa table. Pero kung kayo nanonood lang, wala kayong copy ng table na to, tatagal lang kayo, no? Okay, so malilito kayo, no? So gawin nyo after this class, no? Pag nanonood na kayo sa YouTube, pag na-upload ko na to mamayang gabi, buksan nyo rin tong PDF file para masundan nyo yung pagtingin ko dito sa table. So ito yung ating E-cell for copper 2 plus copper. Again, be careful kasi maraming uri ng equations dyan. Okay, so tignan lang yung copper 2 plus and copper plus. So ang cell potential niya would be 0.15 volts. Okay, so sulat natin dito, 0.15 volts. Saan na yun? 0.15 volts minus yung anode. Ang anode ay tin 2 plus. Tin 2 plus. Sn2 plus. Hanapin natin. Eto. Yan, SN2 plus. So, ano yung cell potential niya? Yan ay negative 0.14. Okay? So, negative 0.14 daw yan. Ay, nakaantok. Negative 0.14. Okay? So, we solve for the E cell. That's negative 0.15 minus negative 0.14. So, that's basically 0.29 volts. So, yan yung ano natin. Yan yung E naught cell. Okay? So, that is 0.29 volts. Tatabi ko na to. Set aside ko na to. Okay? So, that will be the E naught cell. Yun yung ipa-plug in natin dito. How about N? Ano yung small letter N? Sabi ko kanina, the small letter N is the number of moles of electron. No? Paano yon? Paano ko malalaman yung moles of electron? You balance the equation para makita mo yung moles ng electron. Di ba remember, kina-cancel natin yung last time? Kung ano yung coefficient ng electrons doon, yun yung ilalagay mo sa equation na to. Okay? Let's do that. On the top equation, is that balanced already? Not yet, no? So on the left side, we have 0 charge. On the right side, we have the positive 2 charge. So that means we place 2 electrons on the product side. Sa baba, we have 2 times positive 2 charge. So that's equals to positive 4. On the right side, we have 2 times positive 1 charge. So that will be positive 2. So saan tayo maglalagay ng electron? Sa left side. No? So we add 2 electrons so that the charges will balance out. Okay? So ano mapapansin nyo? Ano yung coefficient ng electrons? Kailangan equal na yung amounts nila. So the moles of electron is equal to 2 moles. Okay? So ganun lang. So 2 moles yung ilalagay natin dito. So we have E naught cell equals 0.29 volts. We have 2 moles of electrons. Yung Faraday constant, that is 9648. Depende ko kabisado. 96485 coulombs per mole. Okay. Yung R, gas constant in terms of energy, and T is the temperature. We can now solve for K. No? Solve na natin si K. Reduce ko lang yung equation dyan kasi wala na akong space. Let's solve for the value of K. So K equals exponential E cell times NF divided by RT. So ano yung E cell? E cell is .29 volts. Yung number na lang ilalagay ko, ha? Yung units naman, it is understood that they will cancel out. Sige, lagay ko na rin yung units para makita niyo yung pag-cancel out. Okay, so we have 0.29 volts. N, yun yung moles ng electron. So that will be 2 moles. What's F? That's the Faraday constant, 96485. Coulombs per mole. Sa baba, you have the R in energy units. Okay, dalawa kasi yung R eh. It could either be 0.08206 pag liter atmosphere per mole Kelvin yung unit mo. Pero kapag energy unit sinabi ko, ang gagamitin mong R value will be 8.314 J mol K. Okay. So dalawa yung value ng R ha. Pwedeng 0.08206, pwedeng 8.314. In this particular case, yung energy gagamitin natin. Itong 8.314. Okay? So, yan yung ipa-plug in natin dito. So, 8.314 joule per mole Kelvin. Temperature, ang sabi kanina, 25 degrees. So if you convert that to Kelvin, that will be 298.15 Kelvin. Observe that the units will cancel out altogether. Yung mole, ka-cancel dito. Ano pa? Kelvin, magka-cancel doon. How about the volts, joule, and the mole? Okay, maka-cancel yon sa coulombs, no? So, ano ba yung coulombs natin? Okay, so yung coulombs natin, that is, ano yung unit niya? Ang unit niyan will be ano nga ba yung unit nun? Kalimutan ko yung unit ng coulombs natin. Okay. So anyway, ang unit nun ay joule per volts mole. Okay. So joule per volt mole yan. Yan yung unit ng coulombs natin. Okay. So magka-cancel yung volts, yung joule, and yung mole with the coulombs. No? So joule per volts mole ang coulombs natin. Okay. So with that, cancel na natin lahat ng units. Kaya ang ginagawa ko na lang, numbers na lang nilalagay ko pag ako nagsosolve, no? As long as alam mo yung nilagay mo ay naka-volts, naka-energy yung R, tapos naka-Kelvin yung temperature. Numbers na lang pina-plug in ko. Okay. So we can now solve for E. Solve muna natin itong itong nasa parenthesis. Actually, pwede i-diretso mo na yan sa calcu mo, ha? Diretso na natin. So, that will be E. Asan yung E? Nasa ln banda yan. So, E. Then, gawa ka ng fraction. 0.29 times 2 times 96485 divided by 8.314 times 298.15. Ang laki ng value ng E, ng K, no? So, isa scientific notation ko na lang to. So, the value of K will be 6.38 times 10 raised to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, the value of K is 6.38 times 10 raised to 9, positive 9. So, let's check whether the criteria for K, G, and E are obtained, no? So, meron tayo ay E and K lang. So, ito lang naman yung focus natin. Di ba sabi natin, if E is positive, K must be greater than 1. Okay? So, is that the case for our equation here? Yun yung nangyari, no? So, our E is 0.29, which is positive. So, kapag convert mo yan into K using this equation, ayan, using this equation, we see that the value of K is way greater than 1. Okay, so actually billion yan, no? 6 billion ang value ng K natin. Konting push na lang, 15 billion na siya. Okay, so ganun lang mag-solve ng K from E cell. So again, recall tayo before we proceed with the next question. E cell, alam nyo na yan, cathode minus anode. And that is the number of moles of electron in your balance equation. So, ibabalance mo yan, then you make the electrons equal. Yun yung ipa-plug in mo dito. F, Faraday's constant, 96485. Okay, basta yun, 96485 coulombs per mole. R is the gas constant in temperature, in energy units. Okay. So, ang energy units ay joule per mole Kelvin, 8.314 joule per mole Kelvin. Temperature must be in Kelvin. Okay. So, if you plug in all this in your calculator, you will get this value for K. So, that means the reaction is spontaneous. So, it will form products. Practice pa tayo. So, isa pang item. So, sagot pa tayo isang item. Ano naman? Ito na lang, letter C. Kayo na bahala sa ibang item na hindi ko masasagutan during synchronous sessions natin. Okay? So let's try letter C. We have zinc, copper 2 plus in equilibrium with zinc 2 plus and copper. Okay? Ano gagawin natin? Ano ba yung tanong? Solve for equilibrium constant. So to solve for K, we already know the equation. Sana hindi nyo naririnig yung asa maingay sa background. So to solve for K, that's exponential E cell NF over RT. Hanapin natin yung E cell. Sino yung cathode? Sino yung anode? Mental na lang. Mental. Hindi ko na i-mental para ma-count din natin yung number of moles of electron. Okay? So, sino yung cathode? Sino yung anode? Obviously, yung zinc, ito yung oxidation. Hence, ito yung anode. Okay? What happened is yung kanyang charge ay tumaas na. Yung kanyang oxidation number. Si copper naman, bumaba yung oxidation number niya. So, ito yung reduction. Hence, ito yung nasa cathode. So, E cell equals E cathode minus E anode. Okay? Hanapin sa table. Na-solve na ba natin to? Feeling ko na-solve na natin to. Kunwari na lang hindi pa. So, sa cathode, we have the copper, 2 plus copper. Hanapin sa table. Copper 2 plus copper. Hinahanap ko siya. Saan kaya yun? Ito. So, ito copper 2 plus copper. Again, be careful. May ibang uri kasi ng equation sa baba. That's copper positive 1. So, ito gusto natin, yung copper 2 plus copper. Ang voltage niya ay 0.34 positive. Okay, so 0.34 na positive. How about the anode? Yung zinc. Okay, so tignan natin ano yung cell potential ng zinc. Zinc, ito. That's negative 0.76. Plug in natin doon. Negative 0.76. Solve natin yan. 1.1 siguro to. Ayun, tama nga. 1.1 volts. So, yan yung voltage ng ating cell. Okay, so yan yung value ng ating E. Okay, very good. Then, we solve for N, moles of electrons. So, i-balance natin tong dalawa. So, for the top equation, we have 0 charge on the left, positive 2 charge on the right. That means we add 2 electrons to the right side of the top equation. So, the charges will be balanced. So, plus 2 electrons doon. On the bottom equation, we have 2 plus on the left side, 0 charge on the right side. That means the bottom equation needs 2 electrons on the left side. So, the charges will be balanced. So, ano yung Ne natin? Moles of electron. Okay. So, dalawa. So, 2 moles ang electron natin. Yun yung pa-plug in natin sa K. Solve na natin si K. That will be E cell NF RT. Okay. Values na lang ilalagay ko ha. Kasi we all know that yung units naman, they will cancel out lahat. No? Okay. So, E cell 110 times 2 moles times the Faraday's constant, 96485 coulombs per mole. R is 8.314 times the temperature. We're still on 25 degrees Celsius. That will be 298.15 Kelvin. We can now solve for the value of K. Plug in na lang yan sa calcu para tapos na. Diba, ang laki ng value. K is 1.55 times 10 raised to 37. So that means the reaction is spontaneous because it has positive charge for it has positive value for the E cell and the K is greater than 1. No? Okay. O kunwari, tanungin ko kayo, what is the Gibbs free energy of the two equations we solved? What is the value of delta G? So, delta G solved natin. Burahin ko na tong part na to para may space pa ako. Solve natin si delta G. Paano yung equation na gagamitin natin sa delta G? We can either use negative NF E cell or we can also use negative RT ln K. Ang tanong, will they give the same answer? Ang sagot ay yes. No? So they will both give the same answers. No? So okay lang kahit ano gamitin mo. Okay, so it doesn't matter kasi same lang din yung value na lalabas naman. Okay, di ba nahirapan ako? Saan ko to ilalagay? Dito na lang. Yan. So ito ibababa ko to. So again, when solving for delta G, you can use either negative NFE or the negative RTLNK. So it doesn't matter kung sino gamitin mo. Kasi parehas yun tama. Okay. Ayan, may space na tayo. Imagine nyo na nagbubura ako ng whiteboard. Okay. Ayan, solve na tayo ng delta G. O, dito gagamitin ko ay K. Okay. So, delta G equals negative RT ln K. Paano to gagamitin? Ano lang, o yung R, ganun pa rin. Negative 8.314 joule per mole Kelvin. Temperature is 298.15 Kelvin. ln K, edi ln, tas yung value ng K mo. Okay, so plug natin yan. 6.38 times 10 raised to 9. Okay. So the value of delta G will be, plug in na lang sa calcu. Hindi yan kaya i-mental. So that will be negative R 8.314 T 298.15 ln, then the value of your K 6.38 times 10 raised to 9. So pag pinag-multiply natin lahat yan, that will give us negative 55962.90 joule per mole. Okay, so that will be the delta G value. So as you can see, pag positive yung E mo, pag positive yung E mo, greater than 1 yung K, and at the same time, negative ang delta G. Okay. So kunwari ito positive, ito greater than 1, tapos nakuha mo dito positive, magduda na kayo. Baka nagkamali lang sa sign. Okay. Baka nakalimutan nyo yung negative sign sa harap. Okay. So ganun ha. It is always na kapag positive yung E, yung K ay greater than 1 and yung G ay negative. Okay. We commonly express delta G in kilojoules per mole. So to convert it into kilojoules, that's just divide it by 1,000. So you will get negative 55.96 kilojoules per mole. Okay. So that's our answer. Try natin yung yung delta G equals negative NFE. Try natin lang. Burahin ko na tong nasa baba. Try natin delta G equals negative NFE. Negative NFE. So that will be negative. Ilang moles ng electron meron tayo? 2 mole. Okay. So 2 moles. F, Faraday Constant. That will be 96485 joule per volts mole times E cell. That will be E cell natin? 0.29 volts. Okay. Cancel yung mole, cancel yung volts. Okay. So that will give us delta G equal to negative 55,961.3 joule per mole. Ayaw nga pala, dalawa pala yung mole dito sa coulombs per mole. No? So, dalawa yung mole dito. Kasi coulombs per mole nga pala. So, may matitirang moles sa baba. Okay. So, if we want to convert this to kilojoule, just divide it by 1,000. And as you can see, we still arrive with the same answer. Okay. So, yan. So, parehas lang yung nakuha natin sa dalawang equation. Ano gusto mo gamitin dyan? Kaya bahala, no? Depende sa kung ano given. Kung given yung K, edi yun yung gamitin mo to solve for delta G. Pag given yung E cell, edi yun yung gamitin mo. Pag walang given, kunin mo yung E cell. So, ganun. Kasi yung K, hindi mo directly masosolve yan eh. Yung E cell, pwede mo yung makuha agad. Anong gagawin mo? Yung SRP table lang. Okay. So, titingin ka lang dun sa SRP table. To solve for E cell, then eventually convert that to K or delta G. Okay, so that will be all for that part. Medyo marami tayong di-discuss, no? Pero ganito na lang, no? To help you is inyong i-cover na lessons, no? Babawasan natin yung topic. This applies for modular students din. So yun sa part ng electrochemistry, hindi nyo sasagutan lahat ng question, lahat ng parts doon. Okay. So ikakat natin yun until dito sa concentration of cell EMF. Bawasan na natin yung topic. Yung batteries kasi, kwento ko na lang to mamaya. Okay. So, kwento lang yan. Itong corrosion, makukwento ko rin yan mamaya. And then, electrolysis, di na natin makakover yan. Kasi, alam ko masyadong overwhelming na lahat ng lessons sa inyo. Ang dami na eh. Okay. That's okay lang. Okay. Okay. So, anyway, so ito na, dito na tayo sa second to the last part, no, before batteries and corrosion. Let's talk about the effect of cell concentration on EMF. Okay, so kanina, what can you notice with the problems is that sila ay nasa standard condition. Ano ba yung sinabi kapag standard condition? Ang temperature ay 25 degrees Celsius, concentration ay 1 atmosphere, ang pressure ay 1 atmosphere and ang concentration ay 1 molar. Pero meron tayong tinatawag na general equation din, 'di ba? Yung hindi siya standard condition. So yun yung mga walang not sa taas, no? Okay? So ano gagawin natin dun sa dalawang equations na yun, sa may not pati sa may walang not, no? So we can use those two equations in order for us, no, to determine the effect of the concentration of your species, no, of your ions sa voltage niya. Kasi for example, yung battery, okay, bakit kaya sa tingin nyo bumababa na yung voltage niyan over time? Kasi bumababa din yung concentration ng ilang ions doon, or pwedeng nadagdagdagan yung concentration ng ilang ions doon. So pag binago-bago mo yung concentration ng ions mo, you can actually change the E cell. Okay? Pwede mo mabago yung E cell mo. Pwedeng tumaas lalo voltage niya, or pwedeng mas lalong bumaba yung voltage niya. Okay? So, ito yung gagamitin nating equation. Ito, nasa thermo din to. I don't know if na-cover nyo to. Okay. So, according to thermodynamics, the free energy and the standard free energy, yung dalawang yon, they are related by the equation delta G non-standard equals delta G, standard, or yung not, plus RT, ln Q. So ano yung Q? That is the reaction quotient. And it has an expression equivalent to the equilibrium constant. Okay? So yung K and Q parehas lang yan halos. Okay? Ano yung alam natin? 'Di ba kanina sabi ko sa inyo yung delta G, ano yan, negative NFE cell, 'di ba? Pwede rin yung negative RTLNK. So ano gagamitin natin ngayon? Yung E cell lang. Okay. So negative E cell yung delta G, yung may not, ano yung value niyan? Edi yung negative NFE not cell. Okay. So ano yung difference uli? Kapag may not, ibig sabihin nun, standard condition. Kapag walang not, yun yung non-standard. No? Ito yung non-standard. Ibig sabihin, hindi siya nasa ganong temperature. Wala siya sa 25 degrees Celsius. Hindi siya 1 molar. Hindi siya 1 atmosphere. Okay? So, yan. So, gagawin natin, we will plug in all the equations for delta G and delta G naught. In this equation, we will get this. Negative NF E cell equals negative NF E naught cell plus RT ln Q. Okay. Then anong gagawin natin? We solve for E cell. No? Solving for E cell, okay, so ano lang yan, cross multiplication, so on so forth, you will get this equation here. The E cell equals E naught cell minus RT over NF ln Q. So what does this equation tell us? No? By varying the concentrations of your species, no? Pag binabago mo yung concentration ng species mo, yun yung nasa Q, magbabago yung voltage niya. Okay. So, kunwari, dinagdagan mo ng salt, edi tataas voltage. O pwede rin bumaba, no? So, ganun. By changing the concentration, by changing the value of Q, your E cell can change, no? Pwede yung non-spontaneous reaction maging spontaneous and vice versa. Okay? Na kunwari, battery. Ang ginagawa sa battery natin, they change the concentration so that they will maximize the E cell. Okay. So kaya itong mga baterya natin sa field ng material science, no, especially sa energy, ang ginagawa lang doon to develop new batteries is to identify kung ano yung mga materials with greater SRP values, no? And then babaguhin mo lang yung amounts nila, okay? For example, yung mga cellphone batteries, no? Binabago-bago lang yung amounts ng ions mo doon, no? Okay, babaguhin lang yung amount ng lithium, babaguhin yung amount ng cobalt, no? So that it will give you 5 volts, let's say, no? Okay, so ganun ginagawa nila. Okay, so when creating batteries, hinahalo-halo nila in different concentrations to maximize E cell. Okay, so ito yung equation na ating, ito na yung last equation ninyong mamahalin. Okay, so again, ano yung kwento ng equation na to? This tells us about the relationship of the concentration with the cell potential. It could go up, it could go down. Yung E-cell pwede tumaas, pwede bumaba, depending on the concentration of your substances. Okay? Ang tawag sa equation na yan ay Nernst equation. Ayan. So, si Nernst siya yung nag-derive ng equation na yan. Okay? So basically ginawa niya lang plug in lang siya. Tapos may equation na siyang sarili, 'di ba? Ganun talaga. Paunahan lang nung unang panahon. Let's try some items. Okay? Predict whether the reaction would proceed spontaneously at 298 Kelvin. So we have the reaction cobalt plus Fe2 plus producing cobalt 2 plus and iron, given that the concentration of cobalt is 0.25 and iron 2 plus is 0.94 molar. So, pag nakita nyo, yung concentration ay hindi siya 1 molar. Okay? Kunwari, ayan, 0.25 pati 0.94. So, hindi siya 1 molar. Ang gagawin mo ay, itong Nernst equation. So, ano yung Nernst equation? E cell equals E naught cell minus RT over NF ln Q. Okay? So we can use this equation to determine whether the reaction will still be spontaneous or hindi na. Okay? So when determining kung ito ay spontaneous or di na, alamin natin yung bagong E-cell. Okay? So alamin natin yung E-cell under non-standard condition kasi non-standard na yung ating concentrations eh. So we solve for the E-cell. Paano mo masasolve yung E-cell? Kailangan alam mo yung E naught cell. So solve natin yung E naught cell. Paano? Alam nyo na yung pag-solve ng E naught cell. That will be E naught cathode minus E naught anode, di ba? Sa cathode, just looking at the equation, ano yung cathode mo dyan? Ano yung bumaba yung kanyang oxidation number? Yung
Iron.
iron na. So Fe2 plus naging Fe na lang. So that will be our cathode. Tingin tayo sa table. Again, mabilisan na tingin lang ginagawa ko dito. Pero kapag kayo magre-review, ulitin nyo yung video and then have a copy of the table with you, no? Para yan. Kasi since first year, kailan ko ba ito ginawa? Itong topic na. I think first year college ginagawa na rin namin to. So medyo sanay na kami dito sa table na to. So, ano yung hinahanap ko? Fe2 plus Fe. So andito siya. Magkakadikit lang yun eh. Ito. And so si Fe2 plus Fe, ang kanyang E naught ay 0.44 negative. Plug in natin dito. Dami na pala natin na-solve, no? Negative 0.44 volts. Okay. How about the anode? Ang anode natin will be cobalt. Kasi from cobalt 0, naging cobalt 2 plus siya. So, oxidation yun. Hanapin si cobalt. Hanapin si cobalt. Asan siya? Ayun. Ay, tabunan. So, negative 0.28 volts siya. Type natin dito. Negative 0.28 volts. Pagsamahin ang numbers, negative 0.44 minus negative 0.28, negative 0.16 volts. Okay. So, ano mapapansin nyo? Initially, the cell potential is negative. So, ibig sabihin, not spontaneous tong reaction talaga, no? Hindi mangyayari tong reaction na to. Pero, since binago nila yung concentration, tignan natin kung mangyayari yung reaction. Spontaneous pa rin, spontaneous na ba yan or hindi pa? Tignan natin, solve natin. So, initially, under standard condition, hindi yan spontaneous. Kasi negative 0.16 yung voltage niya. Pero after changing the concentration, tignan natin kung mangyayari yan. Okay? So, that's negative 0.16 volts minus R. Yung numbers na lang ilalagay ko ha. Numbers na lang. 8.314. Temperature, 298 Kelvin daw. Okay. NF, no? So, yung F, Faraday's constant, 96485. N is the moles of the electron. Ito question. Ano yung moles ng electron natin sa equation? Solve natin. So, split mo yan into 2. So, you have your cobalt 2 plus. You have your Fe2 plus to Fe. Okay. Balance mo yan. On the top equation, 0 sa left, positive 2 sa right. So, you need 2 electrons. Sa baba, ganun din, although nasa left yung positive 2. So, dito ako maglalagay ng tig-2 electrons. Okay. So that means the moles of electrons needed for this reaction is 2, no? According to the balancing na ginawa natin. Okay. So ayan. So yan. So we have R, RT, and F. 8.314 joule per mole Kelvin, 298 Kelvin, 2 moles, and 96485 coulombs per mole. How about the L and Q? I don't know if naalala niyo pa yung equilibrium niyo dati. Okay. So, ano yung equilibrium constant sabi sa GenChem? Sabi ng GenChem, ang equilibrium constant ay yung, ano yon? Concentration ng products over the concentration of your reactants. Okay? Concentration ng product over concentration ng reactant. Anong may concentration? Ang may concentration ay yung AQ lang pati gas, no? So yung AQ pati gas yun yung ilalagay, yung solid hindi na isusulat. Okay? Hindi mo isusulat yung solid pati liquid. So that means yung AQ lang yung isusulat ko. Okay? So again, pag Q, yan ay products, concentration over reactants. AQ and gas lang po yung sinusulat. No? Yung solid and liquid, hindi sila nilalagay. Ayan, so GenChem pa yan. No? Sa product side, ano yung AQ? Yung cobalt. Okay. So lagay natin cobalt 2 plus. Sa baba, sa reactant side, yung isusulat natin sa baba, tingin tayo sa left side, ano yung AQ? Yung Fe2 plus. Edi susulat natin yung dito. Okay, so we have cobalt sa taas, yon cobalt. And we have Fe2 plus sa baba. Okay, so yan. So again, AQ lang yung isusulat, pati yung G, no, yung gas. Yung solid liquid, wag isa lang idadamay. Ito question. Sir, what if may coefficient yan? Kapag may coefficient yan, gagawin mo yung exponent. Okay? So for example, yung cobalt mo may 2 na katabi, gagawin mo yung squared. Yung iron mo may 3 na katabi, gagawin mo yung cube. Okay? So ganun. Okay? So ito yung ating equation. Ano na gagawin ko? Plug in. Okay? So ano yung concentration ng cobalt 2 plus? 0.25. Palitan ko na to ha. Balikan nyo na lang sa video. Okay, so 0.25. Yung iron 2 plus, that will be 0.95. Okay, so nasa baba yung 0.95. Okay, so we can now solve for E cell. Solve natin. Sana mag-positive siya, no? Kasi nakalimutan ko na yung sagot dito. Pero kung hindi siya positive, edi sige. Tanggapin na lang natin yung fact na hindi siya spontaneous pag ganun, no? 2 times 96485 ln 0.25 sa taas, 0.95 sa baba. Negative pa rin. Okay. Okay. So, however, medyo maging optimistic tayo. Ano nangyari sa E-cell mo? Nagbago. So, from negative 0.16, tumaas siya to negative 0.14. So, that means, bagu-baguhin mo pa yung concentration. Palit-palitan mo pa yung concentration yan. Pwede maging positive yung E-cell. Palit-palitan mo lang yan, pwede ito mag-positive. Okay? So, in our case, negative pa rin yan, pero tumaas lang bahagya because of the because of the changes sa concentration. Pero still non-spontaneous to. Pero tumaas yung voltage, onti lang. Pwede mo pa to palitan yung concentrations, no? Para mas lalong tumaas yung E-cell until maging positive. Ganun ginagawa ng mga battery manufacturer. May mga salt sila, pinaghahalo sila, tapos depending on the concentration, magbabago yung voltage. Okay, so ganun. So that will be our one example. Let's have number 2. 2 or 3? Parehas lang naman sila. Di 2 na lang. Consider the galvanic cell shown below. In experiment, the EMF of the cell is found to be 0.54 volts at 25 degrees Celsius. Suppose that zinc 2 plus is equal to 2.5 molar and pressure of hydrogen gas is 1 atm. What is the pH of the solution? Actually, nasa module nyo to, no? Okay. So, doon ko nilagay yung sagot din. Pero pakita ko paano nakuha yung sagot na yan sa inyong module. Okay. So, eto, may bago kayong term, EMF. Ano yun, sir? No? Pag nakita nyo EMF sa quiz or sa probset, meaning nun ay yung standard cell potential. No? Electromotive force tawag dyan eh. Electromotive force, aka E-cell. Parehas lang yan ha. Huwag kayo magulat. Baka isipin nyo, ano yun? Di yun tinuro. No? Yan, E-cell yan. Okay. Yan. So, hindi na natin kailangan mag-solve ng E-nut cell. Okay? Bakit? Kasi ito na yun, no? At standard condition, 25 degrees Celsius, ito yung E-nut cell mo. Ay, hindi pala. In a certain experiment pala yung nakasulat. Sorry, di ko nabasa. So, ibig sabihin, ito yung E-cell ng experiment natin. Okay? So, ito yung E-cell lang. Hindi siya yung E-nut cell. Na-overlook ko yung in a certain experiment. Okay. So, anyway, sulat natin. Ang E-cell natin, yun yung 0.54. Pressure ng hydrogen gas would be 1 atm. Concentration ng zinc 2 plus will be 2.5. Then hanapin daw natin yung pH ng solution. Okay. So ito yung ginagawa sa pH meter, no. 'Di ba sa pH meter kung naka-encounter na kayo noon senior high school nyo, 'di ba may nilulublob lang doon na electrode. Yung electrode na yon may hydrogen gas yun sa loob, no. Okay. So yun. Ayun lang. No? So yun, malalaman niya yung voltage depending on the concentration of ions, no? So, depending sa concentration ng ion sa solution mo, may corresponding ano yon, may corresponding pH value. Okay, so let's answer this problem. Sagot na tayo. Sulat nyo yung Nernst equation. Nernst equation. Kung nakalimutan, ano lang yan, E cell equals E naught cell minus RT over NF ln Q. Ngayon pa lang, express na natin yung Q. Just looking at the equation, ano yung Q natin? Products over reactants. Ano yun? Nasa product. Meron kang zinc. So, sulat mo yon. Zinc, 2 plus. Ano pa? Yung H2, gas yan kasi naka-atmosphere. So, kapag yan ay naka-gas, edi susulat mo yan. Okay? So, paano sinusulat kapag gas? Kapag aqueous kasi naka-square bracket. Diba? Napapansin nyo, square bracket yung ginagamit ko. Okay. Ganun kasi kapag aqueous, naka-square bracket. Pero kapag gas yan, letter P ang isusulat mo. pH2, pressure ng hydrogen gas. Okay? Okay, so yan yung nasa product. Zinc 2 plus, pH2, i-multiply mo yung dalawang values na yan. Okay? How about yung nasa denominator? Yung nasa reactant. Concentration ng H plus. Then, nakikita nyo, may coefficient siya na 2, di ba? May coefficient na 2 doon. Anong gagawin nyo? I-square yon pag ganun. What if coefficient niya ay 3? Edi i-cube mo yon. Kunwari, coefficient niyan, 4. Edi, i-raise to 4 mo yon. Okay? So, ganun gagawin nyo kapag may coefficient. Kunwari, ito may cube, ay may 3. Edi i-cube mo to. Okay? So, ganun lang. Hopefully, naalala nyo pa yung equilibrium. Anyway, okay, so yan na ang ating equation. E cell equals E naught cell minus RT NF ln Q, where Q is products over reactants. Ano yung nasa product? Zinc, pati hydrogen gas. So, ganito isusulat yon. Zinc times hydrogen gas. Nasa baba, you have solid and then yung H plus, ions yan. So, lagay mo yung ions dito. Ito, question. Paano mo masosolve yung problem na to? What is the pH of the solution? Asan siya dito sa equation na to? Asan dito yung pH? Okay? Kung hindi kayo familiar kung nasan yung pH, ganito lang yan. Ang pH natin is just the negative log of the concentration of H+. So that means, in order for you to answer this problem, you should first identify what is the concentration of hydronium ion. Alamin mo muna kung ano yung value ng H+. Alam na ba natin? Hindi. Kasi tignan mo yun sa equation, may question mark din, no? Ibig sabihin, hanapin mo muna yung concentration ng H+, so we can answer the pH. Okay? So we are going to solve for this value. So hahanapin natin siya. How? Nasa loob yan ng ln. Paano yan? Ang gagawin nyo? Exponential. Okay? Basta nasa loob ng ln, exponential function ang gagawin nyo. Okay? So before tayo mag-exponential, let us simplify the equation first. Lahat ng katabi ng ln, ilipat sa kabilang side. No? Tawag ng classmate ko doon, evacuate daw. Evacuate natin yung E-cell, pati itong RTNF, kabila din natin yan. Okay? So sige, gawin natin. So yung E-cell, i-subtract mo yun dito sa side na to. Okay, so you have E-cell minus E-not cell equals negative RT NF. RT over NF, ln something. Q na lang isusulat ko, ha? Hindi ko na sulat ulit. Buburahin ko rin to. Then ano na? You have your E cell, E not cell, nalipat mo na sa kabila by subtracting it to this side. Okay? Then ano gagawin mo? Ayun, etong term na to, i-cross multiply mo sa kabila. So, paano mo i-cross multiply yun doon? Di cross multiply lang. Okay? Algebra lang. Okay? So, lnq. Dito na lang yung lnq sa right. So, mapupunta sa taas yung NF, pati yung E cell, minus E not cell. Okay? Algebra lang itong ginagawa ko. Nasa baba yung RT. Then, yung negative sign, madadama yan sa kabila. Lipat mo na sa kabila. So, you have your lnq equals negative NF, parenthesis E cell minus E not cell over RT. To solve for Q, kasi nasa loob yung H plus natin, kailangan tanggalin natin yung ln. How? We get the exponential of the equation na to. Let me copy this na. Lagay ko dito sa kabilang side. Okay, ayan. So, andun na siya. So, again, yung H plus natin nasa Q. So, palabasin natin yon. Paano? I-exponential yung ating equation. So, kunin natin exponential. Exponential ln Q. Plus ito, gagawin ko tong exponent ng aking exponential function. So that will be e raised to this quantity. Okay? So e raised to this quantity, whatever that is. So ano mangyari sa e pati sa ln? Kakancel sila. So you will be left with q equals exponential negative nf. Daming ginagawa, no? Kaya nga babawasan na lang natin yung topic. Kawawa naman kayo. Over RT. Okay? Ang question, ano yung Q? Ano yung Q? Ito. Ito yung Q, di ba? Ayan. Ito yun, di ba? Plug in mo yan doon. Okay? Lagay mo yan doon. So, lagay natin yung Q doon. Okay? Plug in. So, that will be concentration of zinc 2 plus, pressure ng hydrogen gas over concentration ng H plus squared. Okay? So that will be equal to exponential of this term. Ang daming nangyayari, no? Ulitin nyo na lang tong video para masabayan nyo later on after the class. Okay? So yung Q in-express ko uli as this, no? Ito yung ginawa natin kanina pa. Ano hinahanap natin? Yung H plus. Okay, so yung H plus nasa denominator eh. Ano gagawin nyo para masolve yan? Cross multiplication na naman. Okay? Cross multiplication. Walang hanggang algebra. Okay, so that will be the concentration of zinc 2 plus, pressure of hydrogen gas divided by the exponential negative NF, E cell minus E not cell over RT. Nag-algebra lang ako, walang chemistry dito. Algebra lang to. Okay, so yan, nakuha ko na yung H plus squared. To solve for H plus, I will just get the square root of both sides of the equation. Ay, sa wakas, thank you Lord. Natapos din yung derivation. Hindi pa tayo tapos sa solving. Okay. Nakuha ko na yung nakakapagod. Kunin na natin yung H plus. Okay. Plug in ng values. What's the concentration of zinc 2 plus? Basahin yung problem. 2.5 molar daw. So, yung numbers na lang isulat nyo. 2.5 molar. Pressure of hydrogen gas is 1 atm. Exponential. Negative NF, E not cell. Ito, tanong. Alam na ba natin yung N? Hindi pa, no? Nakalimutan natin gawin. So, solve natin yung N. Pati yung E not cell. So, solve natin yung N. Copy ko lang yung equation dito sa taas. Zinc 2H plus. Zinc 2 plus H2. Okay, so paghiwalayin natin yan. Okay, so may H2, zinc 2 plus zinc. Okay, yan. Balance natin. So on the top equation, 2 electrons sa product side. On the bottom equation, 2 electrons sa reactant side. So that means N is equal to 2 electrons. Ano yung E not cell neto? Solve na rin natin E not cell. That will be E cathode minus E anode, diba? From the two equation, our anode will be this one, yung zinc, kasi na-oxidize siya. Yung ating hydrogen, yan ay na-reduce. So, ito yung inyong cathode. Sanapin sa table. Okay, so yung cathode, yan ay 0 volts. Okay. Tignan nyo pa sa table, 0 volts yan. And yung anode, yung zinc, ito, hindi ko kabisado yan. Yung zinc, hindi ko kabisado, tignan sa table. Ito yung H2 0. Okay, kaya siya naka-red. Yung zinc, ito, 0.76 na negative. Negative 0.76. Okay, so yan, pag-add lang natin, 0 minus negative 0.76, 0.76 volts yan. Okay, so yan yung E not cell natin. Yan, so plug in. N is 2 electrons. F is Faraday's constant, 96485 coulombs per mole. E cell minus E not cell. Ano yung E cell? Yun yung sinabi sa problem. Yung in a certain experiment, the EMF is found to be 0.54. Okay. So that will be 0.54 volts minus yung E cell na nakuha, E not cell na nakuha natin. which is 0.76, okay? Divided by R, 8.314 yon, times the temperature, 298.15. 298 ba? 25 degrees Celsius. So, 298.15 yan. Numbers lang pala. Ako na nga nagsabi kanina. So, okay. Ayan. We can now solve for the H plus. Plug in mo lang yan dito sa calculator. That will be 2.5 times 1 divided by the exponential of 2 times the Faraday's constant times 0.54 minus 0.76 E cell minus E not cell divided by gas constant in energy units and 298.15 Kelvin temperature. May nakalimutan tayo yung negative sign. Diba? Ayun na. May negative sign nga pala dun sa harap. I forgot to place it sa equation natin. May negative dito ha. Ayan. Taka ako, laki ng value eh. Mag-ingat dun. So, the concentration of hydronium ion will be 3.02 times 10 raised to negative 4. Okay, so yan yung kanyang concentration in molarity units. No? Sa dulo na nilalagay yung units. So, that will be the concentration of H+. So, to get the pH, that is negative log of concentration ng H+. You just take the negative log of 3.02 times 10 raised to negative 4. So the pH of the solution is 3.52. So ganito yung nangyayari sa pH meters, no? 'Di ba yung nilulubdob niyo sa solution, parang may hangin sa loob. Yung hangin na yon, hydrogen gas yon. So what it does is that depending on the voltage, no, that is passed through the solution, using the Nernst equation, pwede niya malaman yung concentration ng H plus and it can convert it to pH, no? Kaya may pH meter tayo. So, ganun lang yung nangyayari. Okay? So, before tayo mag-proceed sa kwento part na lang. Okay? So, for electrochemistry, dito sa ginawa kong part ng module, actually, marami akong problems dito na sinagutan na before, no? So, you can use them, no? To check whether tama yung makukuha mo sa calculations mo. So, I'll give you some example, no? Ito, binuksan ko na yung ito yung Google Classroom. So, marami akong sinagutan dito sa Google Classroom, no? Download nyo na lang ito. Kasi nung ginawa ko ito, ang dami ko pang time, no? So, yan. Ako na rin, yung question na yan, no? Papakita ko yung solution. Okay? And then, ayan, no? May solution din yan. And so on and so forth. Ayan. Okay, so makikita nyo, andyan na yung detailed solution with explanation. Actually, itong problem na sinagutan natin, andito pala siya, in a certain experiment. Okay. So, andito siya. Ayan. And the pH is 3.52, just as what we solved. Okay, so ayan. Okay, so kwentuhang batteries na lang tayo. Okay. By the way, sa mga magsasagot ng module, hanggang battery yung sasagutan nyo. Itong electrolysis, hindi na natin to masasakop kasi feeling ko oversaturated na kayo ng calculation. No? Okay, so, although madali lang naman to, no? Pero hindi ko na to isasama sa quiz. No? And sa mga magpapasa ng correspondence, no? Kahit di nyo nasagutan yung part na to. Okay. Alam ko finals week yung ngayon, kaya bangag tayo. No? Ang dami nating ginagawa. Okay? So, let's talk about batteries, no? So, sabi ko nga sa inyo, yung batteries, ito ay form ng, Ito ay form ng galvanic cell, no? It produces electricity spontaneously. Kasi kapag hindi yan nag-produce ng electricity spontaneously, hindi battery tawag doon. Okay? So, yan. So, maraming uri tayo ng battery, no? So, isa-isahin lang natin. Ito na yung mga chemicals na nandun. Okay? So, number one will be the dry cell battery. Familiar kayo dito kasi ito yung mga Eveready. Ano pa ba yun? Eveready. Yes, wala na akong alam na ibang brands. Eveready lang yung alam ko. Duracell, ayun, may alam pala ako. Okay. So, yan yung Eveready, Duracell, sila ay form ng dry cell battery. Okay. Ang tawag sa kanila in general ay Lalage cell. Okay. Okay. So, ano meron dito? So, ito yung ating equation that happens in this battery sa ating Duracell, sa ating Eveready. So, what happens is that ito yung itsura ng iyong cell, no? Zoom in natin para mas makita nyo. So, ganito yon. So, you have your paste solution here consisting of zinc chloride and ammonium chloride, manganese 4 oxide, may zinc anode ka, and then you have your carbon rod here, no? So, what happens is that, di ba, kapag pinagdugtong mo yung voltage, pag nilagay mo sa mo ba nilalagay battery? Kunwari, remote control. What happens is that yung remote control, yung circuitry nun, that allows the passage of electrons from here, from the zinc anode, papunta sa carbon. Okay. So, yung electrons magpo-flow from this, then papunta sa circuitry, then babalik yan dito sa battery. Okay. Okay. So, ganun siya. So, dito yung ating anode sa zinc, then papasok yan sa carbon. To sa carbon, graphite, no, yung electrons mapupunta sa mga uh, manganese 4 oxide atoms natin doon. Okay. So what happens there is that yung zinc, it becomes oxidized. So yung zinc magiging ions. And then yung nasa loob ng ating solution, yung ammonium doon, pati yung manganese 4 oxide, they are converted to ammonia and this compound, no, manganese 3 oxide. Okay. So ano napapansin nyo kapag yung ating dry cell battery nauubos? 'Di ba namamasa 'yon? Okay. The reason bakit siya namamasa is ito yung product kasi sa reduction. Tingnan nyo, ano nangyayari? It produces water. Kaya yung battery kapag sira na 'yon or pag ubos na siya, namamasa. At the same time, 'di ba yung ilalim nun parang kinakalawang? Okay. The reason bakit parang kinakalawang 'yon is that yung zinc kasi natutunaw. Okay. Habang nagpo-produce siya ng kuryente, natutunaw siya over time. So kaya gano'n na. Yung ilalim parang nabubutas, parang kinakalawang kasi yung zinc natin na oxidized, nagiging ions 'yon, mabubutas talaga 'yon. And yung nasa loob, yung paste natin ng manganese 4 oxide and ammonium chloride, what happened is that nako-convert to sila into these products. So mamasa-masa 'yon kasi may water na mapo-produce and at the same time mabaho, 'di ba? Mabaho siya because of the ammonia na napo-produce ng redox reaction. Okay? So, yun yung reason bakit siya mabaho, bakit siya nasisira, no? Kasi nasa redox reaction na niya yan. Okay? So, the overall voltage produced by this dry cell battery is typically 1.5 volts. Although, pwede lumaki pa yan, no? Kagaya nga ng sabi ko sa Nernst equation, baguhin mo lang yung dami ng paste mo, baguhin mo yung dami ng metal mo, pwede lumaki yung voltage. Kaya meron tayong 1.5 volts, merong 9 volts, meron 12 volts, 'di ba? So depende lang 'yun sa dami ng ions sa loob ng battery mo. So 'yun yung dry cell battery. Okay? Yung mercury cell battery naman, ito familiar kayo dito. Ito yung mga nasa laruan natin nung bata tayo, no? Yung tawag diyan ay button cell battery. Meron 'yan sa calculator natin, meron 'yan sa relo, etc., etc., no? So, yan. So, yan yung mercury battery natin. So, as you can see, it has the similar motif with the dry cell battery. Smaller nga lang. So, ito yung kanyang redox reaction. You have your zinc amalgam and your mercury 2 oxide, no? So, yan lang. Well, and hindi siya masyado exciting kasi maliit lang siya. Okay. So yan. Ang good thing with mercury battery compared to dry cell battery is that ang mercury battery medyo consistent yung production niya ng kuryente, no? So mas consistent yung voltage production niya compared to the mercury battery, no? Kasi again, bakit medyo hindi maganda yung mercury battery ay itong dry cell battery, kasi 'di ba yung liquid sa loob, no, pwedeng uneven yung distribution, that's why hindi maximum yung ating pag-produce ng kuryente. For kasi for mercury battery, solution na talaga yung nasa loob niya, no? So mas even yung distribution ng ions, so mas efficient yung kanyang pagbigay ng kuryente. So yan, so we have the two dry cell battery, yung Eveready, Duracell, tapos di ko na alam yung ibang brands. And then mercury battery, ito yung button cell battery. Yung mga nasa laruan yun, yung kumakanta ng ayayay, your little butterfly, yan. Next one, lead storage battery. Ito yung mga nasa sasakyan. Pag nakakita kayo ng lead storage battery or sasakyan ng baterya. Baterya ng sasakyan. Ano meron doon? 'Di ba malaking box 'yon. Kung sisilipin mo yung loob noon, may mapapansin kang grills, no? So yung grills na 'yon, they actually consist of lead oxide, no? Lead 4 oxide. And then yung solution doon ay sulfuric acid. Okay? So yung sulfuric acid and yung lead, magre-react yun to produce electricity. A total of 2 volts per cell. So kunwari, may 6 kang cells dito sa yung lead storage battery. So that will be 6 times 2 volts equals 12 volts. No? Yun yung ipoprovide niya sa sasakyan. Okay, so pwede pa lumaki yan. Damihan mo lang yung cell. When I say cell, yun yung compartments, no? Pwede mo kasi palakihin pa yung compartment nito. So 2 volts each yon. So i-multiply mo na lang kung ilang compartment meron dyan. Okay? So ito, yung ating baterya ng sasakyan. So ano meron doon? May lead grills ka and you have your sulfuric acid solution. When they came into contact, pwede sila mag-redox reaction, giving electricity. Ano pa? Yung ating battery car battery, car battery, sila ay rechargeable. When we say rechargeable, ano ba nangyayari kapag nagre-recharge tayo? Yung redox reaction natin, bumabaliktad. Yung spontaneous reaction nagiging ano, non-spontaneous, no? So, 'di ba, kunwari itong sa sasakyan na 'to, yung lead naging ions, pag ni-recharge mo yan, yung ions babalik sa lead, no? So, parang babalik siya sa original state niya. Okay? Kaso ang problema is that kapag ikaw magre-recharge ng lead storage battery, mas mahal i-recharge to kaysa sa bumili ka ng bago. Kaya bumibili na lang talaga ng bago kapag mahina na yung battery. Instead na i-recharge yan. Ang mahal-mahal ng kuryente natin, i-charge mo pa yan, di ba? So, yun. So, ganun. Ito naman, we have the lithium-ion battery. Nasaan yan? Nasa cellphone. No? So, yung cellphone nyo, di ba, flat yon. At each end nun, sa dulo, you have your electrodes. No? You have your lithium electrode and your cobalt oxide electrodes there, no? Sa dulo-dulo nila. Okay? So, nangyayari doon is ganun pa rin, no? So, yung lithium that is being, tignan ko nga equation. So yung lithium, now oxidize siya into ions, and then itong cobalt oxide, ito ay na-reduce, no? So as the electrons flow from here to there, from this side of the battery to that side of the battery, nagkakaroon tayo ng kuryente, no? Gumagana yung ating cellphone. Then kapag nag-recharge ka, what happens is that yung iyong dissolved na lithium ions doon, 'di ba? Yung lithium naging ion kasi yun yung ma-oxidize according to this equation. Pag ni-recharge mo yan, yung lithium ions babalik sa lithium solid, no? And that can be done multiple times, no? Kaya meron tayong lithium ion battery sa cellphone. Okay, so yun lang. So yung flat na yon, sa dulo nun, sa magkabilang dulo nun, may lithium and cobalt electrodes. Overall, they give a voltage of 3.4 volts, although it could be higher. Just change the concentration um, of your ions there. No? Baguhin mo lang yung amounts ng atoms mo dun. And then last one, we have the fuel cell. Okay, so kung naririnig niyo yung yung ano, biogas, no? It can produce electricity. So ito yon, under yon ng fuel cell. So what happens here sa fuel cell, no, for this particular example, no, ang nangyayari is that yung iyong chemicals kasi na nandito sa cell mo, they can give off electricity, no. So for example, yung ginagamit sa Apollo rocket, yung pumunta sa moon last time. When I say last time, 1972 pa yung last na yon. Okay. So ang nangyayari doon is that ganito yung ginagawa ng mga astronaut, no. So may water supply dyan, ay may hydrogen gas supply, oxygen gas supply. When the two reacts, they produce water. And at the same time, they also produce electricity. Kaya nagkakaroon ng kuryente sa spacecraft and at the same time, may tubig sila. Yun yung ginagamit sa manned missions ng Soyuz, Apollo, uh, Space Shuttle, and currently yung sa SpaceX and sa International Space Station. So what happens is that yung hydrogen gas and yung oxygen gas, no, pag inakyat dun sa taas yon sa outer space, kino-convert nila yon into water. So may maiinom sila. And the conversion of water produces electricity, no. So ayan. So ganun. So ayan yung mga uri ng battery natin. So there are four general types of battery. We have the dry cell battery, the mercury cell battery or the mercury battery, button cell battery tawag doon. Lead storage battery, ito yung nasa sasakyan. Lithium ion battery, ito yung nasa cellphone. And fuel cell, ito yung ginagamit sa mga spacecraft. No? Okay, so they can get water. Last na tayo, pag-usapan natin yung corrosion. So when we say corrosion, ano yun? Deterioration yun ng metal because of the redox process, no? Ibig sabihin, nangangalawang, no? So, ito medyo related to sa field nyo kasi usapang bakal tayo, di ba? Mga kabakal kayo eh. So, usapang bakal, riles, no? So, anong nangyayari kasi, yung ating bakals, they tend to corrode, no? Bakit? Because of electrochemistry. Question, bakit nako-corrode yung bakal? Kasi no oxidize sila. Okay? So they get oxidized kaya natutunaw yung ating mga bakal. So for example, ito sa illustration na to, this demonstrates the corrosion of iron, no, when exposed to water and air, no. So nangyari kapag nabasa yung bakal and na-oxidize yung surface na yon, ibig sabihin nahanginan. What happens is that yung ating iron metals, they convert into iron 2 plus or iron 3 plus. Yung ions na yon, they eventually convert into rust, no. Ang rust ay Fe2O3. Okay, so nagiging kalawang yon after the reaction. So ano yung gagawin natin to prevent yung corrosion ng bakal para hindi mangalawang yung riles ng tren, yung nasa basta wala akong masyadong alam sa tren. Nanonood lang ako sa YouTube ng tren. Tanungin nyo si Sheldon Cooper. Maraming alam. Okay, so nangyayari is, ano gagawin natin in order to prevent the corrosion? Okay? So maraming techniques na pwede gawin. Una, pwede pinturahan mo. Okay? Lagyan mo siya ng epoxy primer, no? Yung dalawang solution yun eh, no? So paghaluin mo yung primers na yon so that your metals will be coated against the environment, no? So that yung water molecules hindi siya pwede dumikit sa surface ng bakal. Kasi when your water molecule attaches to the surface of your bakal, konyo, pag-convert yung water doon sa bakal, automatic redox reaction yun. Matic yun. Okay. Spontaneous yun kasi ang voltage nun ay actually pwede kang makakuha ng kuryente doon na. Ang voltage ng reaction na yun ay 1.67 volt. So, ibig sabihin, spontaneous yung pagkakalawang ng bakal. So, ano pwede mo gawin? Pinturahan mo, lagyan mo ng coating, okay? So that hindi siya ma-oxidize, no? Ano pa? So, pwede ka rin tinatawag na passivation. Okay, so ano yung kwento ng passivation? Hindi ko pala yung na-highlight dito. Saan dito yung somewhere? So, ang passivation, ang ginagawa doon is that we attach inactive metals sa surface ng bakal, no? Ang tawag doon ay coating din. Kunwari, yung i-gold plate mo yung bakal or isi-silver plating mo, yun, passivation tawag doon. So, gagawin mo, yung inert metals, ikakabit mo sa metal mo. Okay, para hindi siya kalawangin. So, example, gold plating, no? Copper plating, no? So, yun. Or silver plating. So, ganun yung mga ginagawa, no? Okay, so dalawa yung techniques natin para maiwasan yung pangangalawang, yung redox reaction ng bakal. Pinturahan mo o kaya i-passivate mo. Passivation. Andito yun. Somewhere here. So, passivation, gagawin mo doon is that you will add metal atoms na inactive with water. Okay, so, i-coat mo siya with other metals. So, example nun, gold plating, copper plating, silver plating, etc. As long as hindi siya mangangalawang. Okay? So, yun. So, yun yung yun yung ating passivation. Ano yung mga ginagamit doon? Usually tin, kaya nga ang tawag sa lata ay tin can, no? Yung tin can, may tin yun sa surface, no? Literal na tin yung nandun. Kasi yung tin that is unreactive with liquids, no? Hindi siya nagpo-form ng redox reaction ano, because of the diagonal rule, no? So hindi siya magre-react with H2O. So yan, so hindi siya makakalawang, kaya may tin can tayo. Okay? So, yun. Pwede rin naman zinc yung ilagay mo. Ito yung mga nasa galvanized metals natin. When you say galvanized, ito yung mga yung nasa bubong. No? Diba hindi agad sila kinakalawang kasi may zinc doon. Pati may tin minsan. Okay? So, yun. So, yun lang. So, hanggang dito na lang yung sasagutan ng mga magmo-module, ha? Ito na lang. Ayan. Okay. Pag nagsasagot pala kayo ng essay sa akin, kung magko-correspondence kayo, no, wag na yung super nobela. Okay, so wag na yung sobrang haba na mamaya maiyak na ako sa kwento. Yung just short lang, short and concise answers sa mga ganong questions. Okay? So again, cover na natin lahat, no? Tapusin na natin yung ating lesson. So yon, battery, 4 na uri yan. 4 ba? 5? So we have dry cell. Ito yung mga typical batteries sa ating remote. Mercury cell, ito yung mga button cell. Okay? We have the lead storage, ito yung nasa sasakyan. Lithium ion, ito na yung sa cellphone. And then fuel cell, ito yung ginagamit sa mga spacecraft. No? Yung, yung nangyayari sa pangangalawang ng bakal is that meron tayong redox reaction ng iron to produce iron oxide, no? Or kalawang iron trioxide or rust, no? So, ang voltage nun ay 1.67 pag kinompute mo. So, spontaneous yon. So, in order for you to prevent that, you can either paint your metals so that water will not get in contact with metal, or pwede mo siya i-passivate, no? Passivation, yung mga inactive metals, yun yung ilalagay mo sa metal mo para fast siya, safe. Okay. So, mga nilalagay dyan ay tin and zinc, no? So, yung tin, yun yung mga nasa tin can, obvious naman, tin can. And yung zinc, ito yung sa mga galvanized metals natin. Okay? So, that would be all, no? So, itong electrolysis, we will no longer cover this, no? Although, yan, siguro sa susunod na lang, no? Pwede nyo naman basahin to, no? Although, hindi ko na to ilalagay sa quiz natin, ha? So, also for correspondence learner, please do not answer this part na lang. Okay? So, okay na yung mga pinagpapasolve ko sa inyo kanina. No? So, enough na yon to assess your skills sa calculation. Okay? So, that will be all for our our day. No? So, again, on Thursday, Friday, Saturday, I will upload I will upload the assessments, no? Prob set and quiz yon. So, expect na 40 items yon, no? Total. So, tig 20 yon usually. Okay? And then, kung ano yung grades nyo kay Kuya Daryl, no? Sir Daryl nyo pala, we will compute that na lang na. So siguro wala na tayong exam, no, kasi we have just a few ano na lang, limited time na lang. So kami na bahala, don't worry, no. And yun, pasensya na delayed yung aming ano no, lesson, yung aming lesson. Pero hopefully dito sa mga na-discuss namin, no. Sa na-discuss ko pati ni Sir Darrell, sana may natutunan kayo, no. Okay. So yun lang. So maybe I'll see you again somewhere sa PUP kung magkikita tayo or kung matatapos na ba yung pandemic na to or not, no. So kita-kita na lang, no. Also, I'm planning by ano, by summer. When I say summer, that's ano, kailan ba yun? June, July. So around June, July, I will upload lessons sa YouTube na focus sa discussion talaga, no? Yung mga short videos lang, mga 5 to 10 minutes. Kasi ginagawa ko, di ba, yung entire class discussion, ina-upload ko doon. Gagawin ko by those period of time, no? Sa June, July, gagawa ko ng short lessons, no? So that you can catch up with the lessons kung gusto nyo, no? Or kung may kakilala kayong, ano, yun yung topic nila, pwede nila panoorin doon, no? So, ganun. Magaan na ako. Mag-change career na. The joke lang. Okay. So, yan lang. I'll see you around, no, sa PUP, no. So hopefully may natutunan kayo sa electrochem and sa kung ano man diniscuss ni Sir Darrell. Okay. So again, assessment will be open on Thursday until Saturday. With that, let's end this session na. So thank you for your participation. A copy of the class recording will be uploaded on YouTube, no. Mag-upload din ako ng link sa group natin para may copy kayo. I maybe i-comment ko na lang dun sa post ko kanina. Okay? So, comment ko na lang yung link sa YouTube. So, yun. I'll see you again. If you have any questions with the with the calculations, don't hesitate, no, to reach me out. And also, dun sa module, mas marami akong sinagutan doon. So, you may want to check that then. Okay? So, I'll see you around, no? Bye-bye and stay safe as always, no? Ingat po. And